Our next topics are collusion and first mover advantage. In the previous module, we were talking about the homogeneous goods simultaneous move game with two players, and we arrived at the Nash equilibrium solution. Now, there are some other ways that we could arrive at an answer depending on the scenario, and we're going to talk about two of these different scenarios here. The first question is, what if the two firms literally colluded? Now remember that the market demand curve in this context is P equals 100 minus Q. Well, what does it mean to collude? It means they get together and they work as if they were one. So really this is just going to be as though they were working together as a monopolist. And the question is, what's the best thing they could do for their profitability? Now I need to emphasize that this is generally illegal. In fact, it's pretty explicitly illegal. The only scenario in which this would be legal is if they were merged and they were literally one firm. Then it would be perfectly legal. Anyways, though, just on to the technical aspect of it, we have this market demand curve and we find the monopoly solution associated with it. So when P equals 100 minus Q is the demand curve, MR is 100 minus 2Q. In this problem, carrying over from earlier, we had MC equals 0. So setting MR equal to MC gives us this solution, Q equals 50 and P equals 50. The overall profits then are the product of that, 50 times 50, or 2,500. Now assuming that these two colluding firms just split it down the middle, the profits for firm 1 and profits for firm 2 would each be 1,250, which together makes 2,500. But just to sum up, collusion here would mean a quantity of 25 for each. Q1 equals Q2 equals 25, and so Q overall, the sum of them would equal the 50 we see there, and the price would be 50. Now so far, we've been thinking about simultaneous move scenarios. So either we had the Nash equilibrium where each was doing the best that he or she could, conditional on what the other was doing, and that was a simultaneous move game. Collusion is simultaneous move but coordinated. But now I want to ask a different question. So this is the second scenario in this small module. This is going to be the question about first movers. And so the question is, what if firm 1 gets to move first? And it's not just that it moves first, but it also moves first knowing firm 2's reaction curve. Now, this is kind of an interesting scenario because if you think about it, in general, firm 1's profits depend on both what it produces, Q1, and what the other firm produces, Q2. But in this scenario, since firm 1 moves knowing firm 2's reaction curve, that means that in effect, firm 1 is controlling both 1 and 2. So let me say it kind of clearly. Although 1's profits are functions of both Q1 and Q2, since Q2 is determined by Q1, it's really then just dependent on Q1. So in effect, firm 1 is controlling everything when it moves first, knowing how the other firm will respond to its choices. And given that, what we can do is we can get the demand curve for firm 1 simply as a function of Q1. And then just use our bisecting trick and find optimal output in the traditional way. So let's talk this through. Moving first, and is sometimes referred to as the Stackelberg model in honor of some long-gone German economist. So let's start with the market demand curve. P equals 100 minus Q1 minus Q2. But here's the trick or the key. We also know how 2 will react. That is, we know firm 2's reaction curve, which is Q2 equals 50 minus 1/2 times Q1. If we plug that reaction curve into the demand curve, so right here, plug the reaction curve in for Q2, now we have something that only involves Q1. And we can simplify it, a couple of steps, and we end up right here. P equals 50 minus 0.5 times Q1. That's in effect the demand curve that firm 1 faces. Now, what's MR? Well, I just take and bisect that, same intercept, twice the slope, twice minus 0.5 is minus 1. Setting MR equal MC, given that MC is 0 in this context, gives us that firm 1's best output choice is Q1 equals 50. So moving first, firm 1 chooses to produce 50. In order to find the overall answer, though, we've got to think about, okay, so what is it that firm 1 has induced firm 2 to do? So we know firm 1's output, but we'll need firm 2's output to figure out the price, since the price depends on the sum of the outputs of the two firms. Anyways, let's plug firm 1's output into firm 2's reaction curve, and here's firm 2's reaction curve, 50 minus 0.5 times Q1, which is 50, and so that's 25. That means total output, Q1 plus Q2, is 75. The market price is determined by the market demand curve, P equals 100 minus Q, which in this case means P equals 100 minus 50 minus 25, or 25. So that means firm 1, moving first, gets profits of 50, which is its quantity, times 25, which is price. And those are profits and not just revenue because there are no costs here. So firm 1 gets $12.50 in profit. What does firm 2 get? Well, firm 2 gets the same price, 25, but its quantity of output is only 25, so it gets $6.25. Now let's stand back a second and think about when this might have been advantageous. Remember when they had the Nash equilibrium, that is when we had the simultaneous move Nash equilibrium in this game, the profits were about 1,111 per firm. Moving first gets firm 1 $12.50, which is bigger, and it induces firm 2 to get less. All right, so what are the takeaways from this little module? Well, a couple. First, when you know how your rival would respond, then if you're moving first, knowing how they'll respond, you actually control the outcome overall. And the second point, specific to this model, is that moving first in the quantity game raises the first mover's profit, which is really just an example of the first point.